Hi everybody and welcome. Today we're going to be talking about some real-life applications of slope. So your goal after watching this video will be able to take slope and also y-intercept into real-life context and understand and explain what they mean and calculate them again based off these real-life situations. So the first thing here, a couple of years ago actually now, I was out getting ice cream with my wife and I saw this as a diagram for the pricing structure. And I was like, this is a perfect example of a real-life application of slope. So what we're seeing here, to go up from 1 dip to 2 dips, is we're increasing our price by $1.25. To go from 2 dips to 3 dips, again, we're increasing price by $1.25. But our starting point, our first scoop, doesn't cost $1.25. So what that means here is when we're looking through this, our starting point means something else. And think about ice cream, right? If the individual scoop, the ball of ice cream, costs us $1.25, what's left over? What represents the other 50 cents of that first $1.75? Well, if you think about it carefully, you're going to see it's going to be the cone. And that's what's going to be our starting point here. So again, a real-life example of a starting point and also a rate of change, our slope or increase over time. So to kind of represent that starting point, because finding that cone, that was a bit of a tricky question there. We need to have a good understanding of y-intercept. So we're going to define this first. So this is the point where the graph crosses the y-axis. And if we look at this again on a graph, and let's say it's this ice cream example, right? Where something like this, where we touch or cross the y-axis, that's our starting point. That right there is the y-intercept. We call that our b value in y equals mx plus b. But again, big thing to emphasize here, and I'd even have you write this down in your notes, a starting point. Just think about where do you start in these word problems. All right, so let's take a look at a real life example. I'm gonna put Meredith on the spot here. Meredith has a phone plan. If she uses 1 gigabyte of data, it's going to cost her $50, but maybe she's FaceTiming too much or spending too much time watching Mr. Weird super cool YouTube videos, and maybe it ends up costing her $113 at the end of the month because she's using so much data, 10 gigs of data. So starting point, it's not $50 because she's already used a gig there. That's how much is Meredith paying if she's not using any? So first things first, let's actually skip to number 2. This is going to help us out. What's her slope? Well, we can take any of these points, but we can do something like y2, y1, x2, and x1. So 113 minus 64 over 10 minus 3. And then we'll end up with 49 over 7, or a slope of 7. So a slope of $7, and for every $7 increase, we go up by 1 gig of data. So it's $7 per 1 gig of data. So it's her rate of change or her increase for each extra gig of data she uses. Well, let's think about this here. 0 gigs is our starting point when x equals 0. So if we're jumping by 7, we're just taking 7 away. So it should be $43 there. Another way, if you wanted to go out and calculate this like we did a day or two ago here, we can plug in a y value of 50, an m value of 7, an x value of 1. We don't know b, so we can solve for it. So 2 different ways to show you. You can either jump to 43, or you can algebraically solve to get 43. Either is totally fine. So Meredith's starting point is $43. So before she uses any gigabytes of data, she's paying $43. Well, what's she paying for? Maybe she has a payment plan on her phone. Maybe that's just what her company charges her for access for phone calls and text messages. But we'll call this like her access fee. And if you ever set up the pricing structure of cell phone companies, it is pretty ridiculous, and they have a lot of things they charge fees for. So this is basically before she even starts using her phone for anything, she's paying them $43 just to basically have the privilege to use their network. All right, so we can keep going here. We have our y equals mx plus b equation all solved out now, so we know that it's y equals 7x plus 43. So plugging in something like 20 gigs, we'd be able to do that. And then now we can do an error analysis question 2 for number 4. So again, a real-life context, a real-life situation with some phones, and again, applying it here to some different examples. Okay, so let's keep going here. There's 2 more problems, so we'll go over these. We're not going to do these in the video. I'm going to give you the opportunity to practice some of these on your own here. So we have an example. There's a graph. Leona's delivering newspapers, and it's just asking you for not even what is the slope, but what does it mean? So looking at this example here, it looks like if Leona is delivering, I don't know, like 20 newspapers, she's going to get $5. So it looks something along the lines of her rate of pay for the number of newspapers that she delivers. So actually, we can set this one up. They give us some clear examples here. Let's solve for that slope. Let's find that b value. Let's get y equals mx plus b. And then to finish, let's say what it all means. So m means, or slope means, and I'll have you complete that sentence in your notes. Okay, let's do the same thing for number 6 here. Again, work through these, see what the real life context is, and see, again, when we're actually doing these things, when these things are applying to the real world, what do they mean? How can we interpret them? Not only let's calculate the values, but beyond that, what's the application? All right, everybody, as always, thanks so much for tuning in. If you have questions, again, feel free to reach out, message, email, any of those things. We are here to help. I'll see you in Teams soon.